U.S. Department of Energy's Oak Ridge Reservation is the site of a vital national defense facility and a modern computational and scientific center. But over the years, parts of the reservation have been contaminated with radioactive and other hazardous waste. DOE has been busy cleaning up those affected areas, but much remains to be done. Citizen input is a valuable part of that effort, and DOE welcomes advice from the Oak Ridge Site-Specific Advisory Board, a citizens panel that provides independent advice and recommendations on DOE's cleanup of the Oak Ridge Reservation. The board provides input on a wide range of environmental cleanup operations underway at Oak Ridge National Laboratory, Y-12 National Security Complex, and the East Tennessee Technology Park. You can be part of this important work by attending the monthly meetings of the Oak Ridge Site-Specific Advisory Board. For more information, call or visit our website.
For that, wanted to kick off this evening introducing a couple of new members here. Nanan Jang. Mr. Jang is a Knoxville resident and a graduate student at the University of Tennessee pursuing a doctorate in energy science and engineering. He's part of an interdisciplinary research team with Oak Ridge National Laboratory studying challenges related to energy and applied data science. He has a bachelor's degree in biological sciences from Purdue and a master's degree in microbiology from the University of Illinois. So welcome. Certainly a pleasure having you. And Ms. Harriet McCurdy. Ms. McCurdy is an Oak Ridge resident who retired after more than 40 years as a middle and high school teacher in the U.S. and abroad. Most recently, she taught science and biology for grades 6 through 10 at Yangon Academy in Myanmar. Prior to that, she taught a variety of science and environmental studies courses in China, Morocco, Kuwait, and Ecuador. Ms. McCurdy received a bachelor's degree in biology from Earlham College and a master's of arts in teaching and biology. She received her teaching certificate from Washington University. So welcome aboard. Pleasure having you. I'd also like to extend my thanks to all the board members who take time out of their evenings to come and contribute to this. Certainly appreciate that. I understand that takes you away from other things you might prefer to be doing. So we certainly appreciate you coming and supporting us here and look forward to continuing to get your assistance in the cleanup program here. Shifting gears a bit, I did want to cover a couple other things while I've got your attention. I want to introduce Laura Wilkerson here. Many of you may know Laura, but recently she was selected as the deputy manager in Oak Ridge. You know, we've been operating with a rotating cadre of acting managers, including Dave. So I'm happy to finally have a good deputy manager, and Dave's happy to be rid of me making him go do stuff he didn't want to go do. So certainly happy to have Laura on board. She previously was the director of our project or program management division, or project didn't help me. Thank you, planning execution division. You'd think I could remember that, but and so she's had 20 plus years experience here. She started when she was about 15 years old. So, but I'm certainly pleased to have her on board. Christoph may talk about it a little bit more, not trying to put you on the spot, but I know TDEC has a new commissioner in place, and I guess just announced a deputy commissioner. I saw tonight, at least. You guys probably knew that. And Mr. Salyers, the commissioner, will be in town next Friday. He's speaking at ETEC, and I actually get to meet with him, so I'm looking forward to that as well. And then out at ETTP, we continue to make really good progress. For those familiar with the site, this week we started tearing down the K-1037, the old barrier plant. That was the next biggest facility left on site. So after that's the centrifuge buildings and some cats and dogs. And so we're making very good progress out there with the D&D and on track for Vision 2020. And then finally, the History Center, we hope to have that open by this fall. So we'll look forward to folks coming out there. I know it's not necessarily directly related to the activities of the board here, but certainly we'll have an event out there that'll be open to the public, and look forward to folks coming out for that. So with that, I'll turn it over to the speaker, or back to you, sir.
Thank you. Connie Jones, EPA.
Thank you. I don't have any specific announcements to make, but I'd be more than happy to attempt to answer questions if asked. Thank you.
Thank you, Connie. Christoph.
Good evening, everyone. Like Jay said, you know, TDEC, Tennessee Department of Environment and Conservation, has a new commissioner, David Salyers. 2 days ago, it was announced that we have a new deputy commissioner, and his name is Greg Young. Greg Young comes from the environmental field. He's an environmental attorney. He's very much familiar with regulations. He was on both sides, representing, private business, representing TDEC. So we have commissioner and deputy who are very much involved and interested and knowledgeable about the environmental issues.
Excellent. Thank you. With that, we can move into the presentation.
Well, I'm going to talk tonight about our, basically the status of groundwater contamination on the reservation, our history of investigating that contamination. I'm going to talk some about what we've done already to attempt to restore groundwater and basically remediate that contamination, and then some about an area where we could use some decisions so that we can get on with other final groundwater remediation projects. And then, of course, time for questions. There we go. Okay. One thing I want to stress at the outset is that we do have a pretty big groundwater program in Oak Ridge. We've been investigating groundwater for closing in on 4 decades now. Basically, the groundwater problems on the reservation are associated with old burial grounds that have been infiltrated with groundwater, contaminants being carried from the rainwater down to the groundwater, and then spills that have taken place, much like other groundwater problems at other industrial facilities. Nothing special about Oak Ridge, although because of the scale and widespread nature of all the industrial activity in Oak Ridge, there are some significant groundwater problems. I'm not going to read through all this, but just some interesting statistics. We've got over 2,000 wells that we've put in place on the reservation to allow us to get a handle on where groundwater contamination is and isn't, how groundwater behaves in the subsurface. We've invested heavily in understanding that. We do have an active monitoring program in place. Every year we take about 800 samples for water quality measurements, where we actually pull the water out and analyze it for contaminants and basic water quality parameters to understand water quality. Then we take about 1,400 water elevation measurements. That really gives us a better handle on how groundwater is moving around. And then because of the interconnectivity between groundwater and surface water, we have a lot of investigation continuously underway on surface water areas. All of that material, all that data is summarized annually in a report called the Remediation Effectiveness Report. We've had a practice of presenting that report before this board about once a year to speak to what the New Year's data has told us. Rough statistic, we plan on spending about $13 million in 2019 just maintaining those systems. Obviously, we've got tens, if not hundreds of millions invested in creating those systems. This is a kind of an eye chart, and I'm not going to go through everything here either, but basically the message I want to be clear about is that we do have some form of groundwater cleanup system in place in essentially every valley on the reservation. They're there as interim actions. They're not final remedies, but they're things that we've put in place to try and get a handle on the most significant of the groundwater problems. A couple of the more significant ones on the, does this have a laser beam on it? Green button. There we go. Right over here, these purple shaded in areas are areas where there's groundwater contamination. So at Y12, which is right here, and in Bear Creek Valley, same valley actually, but there's a groundwater divide here. Groundwater flows that way from, anyway. So we've got a groundwater capture system right here, and that's set up to capture contaminated groundwater, pull it out of the ground, treat it, so that we can prevent extensive migration of the water off-site. You can see there is just a little bit of a plume that still comes off-site from that. It's actually retracting some, which is good news. On the western end at the Bear Creek Burial Grounds, we have a groundwater collection system, same basic idea, although there it's more of a passive system. The water upwells from beneath the burial grounds. We capture it and take it off for treatment. Over at Oak Ridge National Lab, we've got a system right there, right in the heart of the most significant source of groundwater contamination at the lab. It's referred to as the Core Hole 8 plume, but it's a location where there was an underground tank that had a pipe coming to it. The pipe came detached from the tank, was detached for quite some period of time, and just discharging its contents down to the tank and down to the groundwater, creating a fairly significant groundwater problem. So we have interception systems in place for that also. Across the ridge in Melton Valley, which is basically the burial grounds for Oak Ridge National Lab. They're closed now, but they operated from the 40s up until, I believe, the early 80s. They involved really low-tech, old-style burial practices where they would just excavate trenches. They wouldn't line them. They were below surface. In some cases, the trenches went down to groundwater. They would emplace the waste, cover it back up, and it created a bit of a groundwater problem. So there we've implemented about a $250 million-ish remedy designed to do everything practicable to isolate the waste from the groundwater. It has been largely effective. Our goal was to ensure that by the time this valley drained through a system of creeks and made it to the Clinch River, which I'm sure all of you are familiar with, beautiful river, serves as a drinking water supply for a lot of people, that the water quality was right about drinking water standards right there. And while many years ago, before we implemented this remedy, it did not meet those standards, now it's doing pretty well right there. It's basically, we've lowered the water table in most areas. We've put impermeable caps over the top of the waste burial ground so that water can't infiltrate down into the waste. And then we have collection systems surrounding the burial grounds where they could be installed to catch any water that flows laterally through the waste. It's taken up and treated at a water treatment plant. In other areas, and I'll stop speaking about all of them, there are several more, but in other areas, our focus has been on simply excavating the source that produces groundwater contamination. Recall I mentioned that we're talking about burial grounds that contain hazardous materials that have leached and contaminated groundwater. And there are several burial grounds around the reservation where we've basically excavated those out. I'll talk some more about that. In the case of Melton Valley, we did not excavate the burial grounds. They were closed in place and isolated. The construction cost for all those groundwater capture systems is in the range of $33 million. The costs associated with the excavation, or we sometimes refer to it as source control measures, would range in the tens to probably in excess of $100 million also. We spent about $3.5 million just maintaining those systems. Okay, the first priority, probably the first priority for Oak Ridge cleanup programs is to make sure that no member of the public is exposed to contamination. So we've placed extra emphasis on ensuring that we understand and control any contamination that's migrating towards off-site locations. And the area where that was most probable was, in fact, the Melton Valley burial grounds. This is a close-up view of what we were looking at before, basically the southwestern portion of the Oak Ridge Reservation. If I can orient you a little bit. Oh, dang it. Sorry about that. Okay. Oak Ridge National Labs is over here. Melton Valley, all those burial grounds is right here. And in this location, you have burial grounds very proximate to the Clinch River. And just across the Clinch River, right in here, are private residences on private wells. So you can literally, I've met all these people. You can stand on this side of the river, look across, and essentially see the burial grounds. So it's very close. It was an early priority for us to put in a series of wells that allowed us to monitor, we call them picket wells, to monitor right at the edge of the river. And then we elected to go ahead and put in public water supplies for everybody that lives within an area defined by this road, the river, and down to here, and then the interstate. I sometimes jokingly refer to that as the zone of generosity because that's the area within which DOE buys people their water to make sure they're off their wells. We spent a few $100,000 putting in water supplies, and we pay their water bills. Excuse me. It would have been very expensive for people to do that for themselves, and this is just a way that we can be absolutely certain that people aren't in harm's way. There wasn't a lot of evidence of big problems over there. There was like smoke, but not fire. We felt it reasonable to put that in. We continue to maintain those systems. We continue to monitor a collection of wells on the other side of the river. And we're going to put in some additional picket wells right in this area so that we make sure we have a good handle on what's going on in Bethel Valley also. You can see Bethel Valley comes across and into the zone of generosity, so those people are on public water supplies. But we don't have a really good coverage on wells in through here, so we're putting some in there. We've got a quote here that we're happy about. We have analyzed a lot of data over here over the years and have been able to conclude, and this is actually a quote from EPA, that there's no current indication of a public health threat associated with offsite groundwater contamination. Closing in a little bit more, same valleys. Go through this pretty quickly, but again, the big emphasis, or a big emphasis, is making sure that these burial grounds that are close to the river are understood, the groundwater plumes are understood. Good coverage in Melton Valley right here, though each of these green dots is about $1 million well. We need to put some of those green dots up in here. That's what we're going to do. We may at some point need to add to these wells. I've got a thing here that it says no new wells needed for Melton Valley. I wish that had been worded a little bit differently. No new wells are planned in the near term for Melton Valley, though at some point, if we feel we need new wells to understand what's going on, we'll look at that. And as I mentioned again, we're still paying for about 400 residences worth of drinking water supply. And they can fill their pools, water their cattle, whatever they need to do. Okay, I'm going to spend the rest of my time talking about the East Tennessee Technology Park. Is it possible to make a little bit darker in here so that shows up better? Little darker. Thanks, that's perfect. All right. So this is the East Tennessee Technology Park. It's up at the northwestern corner of the Oak Ridge Reservation. It's been the most intense focus of our cleanup program for the past 15 years or so. It's actually the one tract of land that, in effect, Jay Mullis owns. Jay doesn't own Oak Ridge National Lab and Y12, but that one is actually under his domain. And we are focused on getting it cleaned up as our first big accomplishment in Oak Ridge, and we're really getting there. If this picture was 10 years older, this site would have been covered with buildings. There were enormous buildings located right here. In fact, a building that was one time the biggest building in the world. Comparable buildings here. The site was covered with buildings, and now it's by and large a bunch of empty fields. We've got a few more big jobs to do before we can be done with the building work, and we've got some soil work to get done. But our basic objective is to defederalize that entire land area. So a couple terms that'll help the conversation during this presentation and then our subsequent discussion. We call this the main plant area on this side of the creek. Main plant area. This kind of oval-shaped property we call the K3133 site. We call it that because that was the K33 building and that was the K31 building. Call this Duck Island, even though it's an isthmus, and we call this the powerhouse area. You can kind of tell just from the pictures that the industrial history has been much more intense in these areas. They had the greatest potential to become contaminated. This one absolutely did become pretty severely contaminated. These had less industrial activity, and the groundwater conditions there are fairly straightforward and not too bad. So let's move on. We'll talk. What I want to do is spend a few minutes talking about that site, the K3133 site, and this site, and our nearer term plans for dealing with groundwater at those sites. Okay, this is an aerial looking straight down. Orient you real quick, K3133, and the main plant area. I promise I'm not going to go through all these, but we have invested a lot of money on these two properties on controlling groundwater contamination. The highlights are we dug out a burial ground there, which served as a source of contamination. The greens, obviously, the plume. Dug out a big burial ground right down in here somewhere. It was I think it was called this 1070 CD pits, and it was an area where They basically took solvents and poured them into a pit and allowed them to percolate down into the ground. There was some drum disposal there too, but that was a pretty good source of contamination. An area right here where there were a lot of machine shops, and those machine shops had floors and tanks that contained large quantities of solvents, materials called trichloroethylene, perchloroethylene. Those solvents were used extensively to degrease equipment, to clean equipment, to cool in some cases, and those tanks and sumps leaked. So you end up with a pretty much first-rate groundwater challenge right in this area. We've got, so in addition to the burial ground excavation activities that are already taken place, we've also got some groundwater intercept systems in place. I won't walk through each of them, but there are several. Hear that rain. Okay, let's talk about the K3133 site for a minute. This is about 200-ish acres of the flattest ground in East Tennessee. It's got enormous power supplies coming to it. It has rail access coming right up the side of it. There's a barge terminal over here, interstate, a few miles that way. It's basically an ideal site for reuse for industrial purposes. And that is what we hope to see happen over time. We've already completely remediated the surface of the site. The buildings are gone, the soil's been cleaned up, and in fact, the property's gone through this elaborate process involving EPA approvals and state of Tennessee approvals, actually a letter from the governor, a letter from the regional administrator, and then actually a congressional review prior to being transferred to the private sector. So that site is now owned by an industrial development authority that manages the entire ETTP area called CROET. So we've got decisions on the buildings that are implemented, got decisions on the soil that are implemented. We don't have decisions on the groundwater, and it would be great to get them. The story on the groundwater there is not too bad. The primary issue historically out there was that there were firewater lines that ringed the site to provide fire water, in some cases cooling water, to the industrial systems at the center of the site. Those water systems contained chromates, which are a very water-soluble material that are intentionally introduced into that type of water to prevent oxidation, corrosion of the piping and such. In some cases, those systems leaked, so the set of wells that we've got out there, I guess about 21 wells in place now, most of them in place for several years, we're able to detect isolated areas where there was some chromate contamination present in the relatively shallow groundwater. That's not at all a surprise. Chromate's super water soluble, so you'd expect to see it in the water. The levels qualitatively were in the range of drinking water standards, sometimes below, sometimes above. Kind of hovering around drinking water quality for several years, generally trending down. For the last year, they have been consistently below drinking water standards, I believe. That's my understanding. So we think we've basically seen that site flush itself out. A good thing about living where it rains a lot is that shallow groundwater systems tend to be flushed by rainwater as it comes down. Basically, what's been going on is the water's been being pushed to the stream surrounding the site. And now we seem to have a pretty good situation with respect to groundwater there. So we're going to be promoting a decision called a no further action decision for that site, which basically means it's been characterized, the problem's understood, the problem isn't a problem, and we can let go of groundwater investigations and further action for groundwater out there. That's what DOE thinks is reasonable, but we make final decisions in collaboration with the state of Tennessee and EPA, and that process will be taking place over the next several months. It would be good to get a decision made because when the Industrial Park Authority shows this property to a private prospect, they say, well, what's the deal? And he talks about the governor signed a letter and EPA signed a letter and the surface is all clean and all that. And then they ask about the groundwater. They say, well, we don't have a decision yet on the groundwater. And that tends to scare people off because they don't want to invest heavily in a site where there's any possibility that DOE and its people in Tyvek protective gear and drill rigs are going to show up and kind of erode their ability to use the site's surface. So it would be good to get a decision, ultimately, whatever that decision is. There are wells around the edge of the site that might serve as long-term monitoring systems, but we We think that that's not even necessary. We think that this site is basically ready to go, ready to be reused, but we'll work on that for a while. Okay, talk about the main plant area a little bit more. Again, this area, I can't remember how many acres it is. I think it's about 300 acres. And the main plant area is kind of the opposite from K31. It definitely has groundwater problems. They're complicated. They may be intractable in some areas. Like the K31-33 site, it is generally ringed by surface water bodies. The site, the general model for groundwater contamination at the site, not a complete explanation of behavior in the subsurface, but the general model is that contamination is flowing to those surface water systems. We've got, in pink, a plume of technetium contamination that came from basically the old K25 building. Essentially everything else that you see in green, red, and yellow is they call halocarbon solvent contamination, trichloroethylene, perchloroethylene. The worst of it, kind of the ground zero, most contaminated areas right there, that is also under property that we have transferred, is now privately owned. We spent a couple of years investigating that area as a potential site for deployment of a technology called in situ thermal treatment. In situ, I guess, is Latin for in place. Thermal, you know what thermal is. The idea was that you drop thermal probes down into the ground, heat the ground up, cause these solvents to volatilize and be driven off and away from the soil. So you actively kind of push the material out with heat. And we spent, just to position ourselves to design such a system, we put in close to 100 wells in an area of land about 1 acre in size. It's probably the most perforated acre of land in North America in terms of well studies. Put that in, several $1 million to get that done. Got a really strong handle on where the contamination is and isn't, what contaminant levels were present, how much of it was in bedrock, how much of it was in the shallow zone, and then brought in a bunch of experts. And the general conclusion, as I understood it, a biologist listened to hydrologists, is that it would be very difficult to deal with the materials that are in the deep bedrock using thermal technology, but that it would work in the shallow zone, basically the shallow groundwater zone. The problem is that if you clean up the shallow zone but don't clean up the deep zone recontaminates the shallow zone, so it's a really tough problem. If you attempt to heat up the deep zone, what can happen is that you hit the boiling point of these solvents, they spread out, they hit cooler soils, cool back down, and you basically spread the problem out. So there's actually the potential that you could make things worse while you're trying to make things better. So treatability of deep bedrock using in situ doesn't look like a winner. It's still under consideration. We'll talk about that in a minute for the shallow zones. We're continuing to add wells out there at EPA and TDEC request to position ourselves to do a treatability study, basically, to position ourselves to make decisions for that area. Okay. Now I'm going to show you a short video, I think, that helps me get a better visual sense of what's going on. So this is an example of a tank. Subsurface tank that might have been used for these degreasing operations. Could be as big as this area within the tables, filled up with perchloroethylene or trichloroethylene. As that material gains grease and grit and grime, it's recirculated and cleaned through subsurface piping systems. Those leak, that results in contamination. This is the area over that 1 acre of land that we talked about. And here you can see a whole series of tanks. I always just have to point out these tanks are heated. You can see the vapors coming off of that, and there's a worker right there. That's, to me, just fascinating. We obviously would not allow that under today's safety standards, but that's a 1940s era degreasing operation. Now we're going to see the big picture. There's some burial grounds up here that we dug out. Noses up. And what's going to happen now is we're going to get right on top of the area where the contamination was dispensed, if you will, and we're going to show slices of subsurface conditions. Each one of those light green spots are where there were tanks. The light green area right around here, now we're going to get on top of it and just show what the subsurface conditions look like. Keep in mind that you get to groundwater in about 20 feet. So you got dry ground for the top 10, 20 feet, then you hit groundwater, another couple, 10 feet, 30 feet, you hit bedrock. Everything below that is bedrock.
Say it again.
Dennis, what's the depth to groundwater?
Depth of groundwater is about 8 to 10 feet. The overburdened soil is down to about 17 feet. Weathered bedrock to about 26 feet. So bedrock on average.
So we estimate we have around 536 pounds of TCE, trichloroethylene. This is a technical term. I probably came up with that one. It shows the subsurface kind of from slices from a different angle. I think one point that anyone can draw from these slides is that we've done a lot to get a very, very solid handle on what is down there and what the subsurface conditions are like that. So in this area, the main plant area, we aren't proposing no further action because everything's so clean. In this area, we're proposing and actually executing a study of options for dealing with the groundwater in the area. We're doing that with EPA and TDEC. The study we do is something called a feasibility study. The objective for this feasibility study is to take a range of representative options for dealing with the groundwater in the subsurface and analyzing those options from multiple angles. One, of course, would be effectiveness of the option at restoring groundwater. Another would be the cost of the option. Another would be the implementability of the option, how likely it is to work from an engineering perspective. Something we're interested in making sure we get a good handle on is how the options would impact surface reuse potential at the site. And then there are other parameters, but basically there are, I think, 9 total criteria that we're required to look at in evaluating the effectiveness of different options, and that's what we will be doing. Qualitatively, the types of options we will look at will include, essentially all of them are likely to include excavation of readily accessible source material. In fact, we're out there digging up the readily accessible source material now. We're digging up all, well not all, but a lot of the technetium contaminated soils that cause this plume. We're going to work our way up here and dig up a fair amount of soil. There will be a lot of digging going on to prevent release of contaminants from the material that can be practicably excavated. In addition, we are going to look at, we'll probably have one conceptual option that says, let's just try to control things at the boundary somewhere. Maybe not all the way at the edge, but basically try to keep the problem from getting any worse. Impose use restrictions throughout the site so that no one actually build into the deeds use restrictions that preclude anyone from ever pulling groundwater over the site, and implement a essentially multi-decade monitoring program. There's also, it's not mentioned here, but there's some possibility that biological methods might be useful in remediating some of this groundwater. The idea is that you either take advantage of naturally occurring indigenous microfauna to eat up the contamination. You might inject some food down there to stimulate their growth and get them going on eating up the contamination. And we'll look at something called monitored natural attenuation, where basically you use time and, in effect, dilution to allow the plumes to dissipate. And as I mentioned earlier, there's almost certainly going to be areas where we conclude we just can't fix it. All we can do is prevent people from drinking it. And maybe we can keep it where it is, but there's a term for that in regulatory parlance. There's a protocol called a technical impracticability waiver that we can seek from the EPA and TDEC to allow us to leave some contamination in place, and that likely will be necessary just because we can't get the cows back in the barn from that deep bedrock. We're set up to deliver the feasibility study to them. We're writing it now. We're set up to deliver the feasibility study in this coming fall. Probably at that point, we'll give the regulators some time to look at it and see if if the conclusions provided by it are on target or way off. We'll get their comments. We'll tighten up the study a little bit. Then we'll probably come to this group and discuss with you what we've learned about the range of alternatives and their likely effectiveness so that you can help us move towards actually making a decision. As you're probably all aware, the decision starts with a proposal. It goes out for public comment. Current date for a record of decision is still pretty far out. We'd like to beat all these dates. There's a national park that's trying to get built right here. There's a fair amount of private land that would be nice to reuse right here. And in some ways, those objectives for the surface are hindered by the lack of decision-making in the subsurface. So this is going to be a hard project because the problem is so complicated. It's difficult for people to let go of groundwater. So there's going to be a lot of people who want to see us put in a real good college try at remediating it. It's just going to take some time, but hopefully this fall we'll have a study available that gives people a sense of what the options are and how they compare to one another against criteria that are used to judge those remedies. And I think that is the summary, and we can start the question and answer period. Yeah, but I think it says, oh, I'm sorry, I got a summary slide. Let's go to it. That's right. I've been trained, but not very well, to always wrap it up. So the take-home messages from DOE's perspective are that we do have a lot of wells. I mentioned about 2,000. We think we've got a pretty good handle on what the problem is. We continue to spend a fair amount of money to manage that problem, though we do continue to install some wells. We're working with EPA and TDEC to identify any areas where additional wells might be useful. Might be some problems we can't solve. I think that actually I would go so far as to say there are some areas where there are problems that we can't solve. But we think that we have enough information to begin making decisions. And it's very important to make decisions because until you make decisions, you don't have a path forward. And also until you make decisions and implement your path forward, you don't know what the site surface reuse options are. So that's the last slide. Now we can go to questions. It says questions, yeah.
Thank you, Dave.
Sure.
Questions? John? Oh, Bonnie, sorry.
Did you say, Dave, that the 1070 CD burial ground has been
It was
excavated and cleaned up?
There's actually a complex of burial grounds in that area. There's a
Right.
large classified burial ground up on the hilltop. It has not been excavated. The reason it's being left in place is because of classified materials.
Yeah, it's
there.
probably non-hazardous.
It is classified up there. The lower areas where there was pit disposal of solvents, it was excavated.
And what about the one at 31 and 33? Has it been remediated as well?
The one,
excavated?
that one is the 1070.
I can't remember, 1070
whatever.
G, maybe, I don't
She
know.
knows because she helped dig it up, but
Yeah.
it's to the northwest, and it was dug up. Although we may have to go back into that one and dig up a little bit more.
Okay.
But it was excavated once.
Okay.
Dave, 1070B was also excavated.
Okay, thanks.
John?
In that, the next to last slide there, you described where you're digging up all the soil material to help with the situation there. Where's that soil material going for disposal?
It's going over to the on-site landfill in Bear Creek Valley.
EMWMF?
Yes, EMWMF.
Bill?
They load it into trucks and haul it over there.
I've got 2 or 3 questions.
Sure.
Bill, could you use the microphone, please?
Yeah, I've got 2 or 3 questions involved there. My history involves quite extensive drilling, water wells, gas wells, oil wells, 2,000-foot fence post holes, such. So I was just curious about the depth of the wells, the shallow ones, the deep ones. How deep are they running?
Variable. We have a lot of the wells we put in place there's a cost-effective technology that allows us to put very small, basically push probes into the ground where they're maybe 1-inch diameter things. Those typically would only go 10 or tens of feet. When we're trying to go to bedrock, we typically would go tens to hundreds of feet. Some of those picket wells go several hundred feet. So we've got wells at all depths.
Did you pump the wells to
Oh, yeah.
Extensive? What flow rate did they?
I couldn't tell you the flow rate, but I know that some of the wells are pumped for days to develop them to allow us to make sure we get representative samples.
I've had wells that'd take 2 weeks to get
Yeah,
to
yeah,
clear up to
yeah, yeah.
stuff as pumping 20 gallons a minute.
There's a really rigorous defined protocol that we agree to with EPA and TDEC for putting in, developing, and utilizing these types of monitoring wells. It's a pretty developed science at this point.
Along that acre site, they pump those extensive to clean that.
I'd guess that any of the true boreholes that were put in, developed wells were developed. Yeah.
They pumped them quite extensively
Yeah.
to get that.
David, yeah, we did a couple of pump tests at that 1401 area, and actually, we were only able to pump at less than 1 gallon per minute, and the wells would go dry, so there's not really even much usable water.
Yeah. That's a common situation. A lot of these areas where we have contamination and have groundwater, it probably isn't really a future drinking water
That
resource.
was probably at 100 feet, 150 feet.
Yeah, at that location, we drilled wells to about 150 feet.
I wouldn't expect to find any drinkable water to, 300 or 400 feet.
Yeah.
250.
Anything else?
So that's basically it.
Okay,
I
thanks.
may have something later.
That's
I'll
fine.
reserve to come back later.
That's fine.
Fred?
Yeah, just to follow up, kind of on Bill's question, to what extent do you pump the water and treat it and then return it, by whatever treatment methods, activated carbon or something to get
Right.
stuff out of there? Is that done extensively throughout?
Several of the systems that I kind of blew past very quickly involve pumping groundwater, treating it, and discharging it. It's generally discharged not back into the ground, but into a surface water system. But I believe certainly the Big Springs plant at the center of Y12, which basically captures a bunch of spring water, treated, discharged. The East End VOC plume management system at the eastern end of Y12, same thing. The Bear Creek Valley treatment system involves pulling up groundwater, treating it, discharging it. So I'm unaware of any system where we basically recirculate the water and put it back down to the groundwater. And there's no system where we treat water and introduce it for drinking water use. In all cases, it's treated to whatever standard we've agreed to and discharged into a surface water system.
Circulate to clean it.
We don't have any recirculating systems, I don't think. We just pull, in a lot of cases what we're trying to do, as much as clean the water we remediate, is attempt to control the migration. So we're pulling groundwater for the purpose of keeping a lot of stuff from migrating. So putting the water back in the ground doesn't serve that objective.
And
Lots of them.
Yeah, so you had mentioned some biological approaches. What's the feasibility and challenges do you foresee for bioremediation approaches?
The one place where I know that we tried it was actually at Oak Ridge National Lab, and it was a halocarbon plume. That one involved, we did some work to determine what was already there, and we concluded that the microbial ecology of the groundwater already sustained the life forms that we were interested in. So they injected something, probably some, sucrose or fructose or something, and it worked. It did result in acceleration of the degradation of the solvents and the concentrations in that we saw evidence of degradation products and all that. We stopped that, and I can't tell you, maybe Dick Cattell can, if things rebounded or if they...
Bonnie?
Yeah, Dave, you mentioned when you withdraw the groundwater and treat it and discharge it to surface water, drinking water criteria is what you use, as opposed to water quality criteria?
Typically be water quality criteria.
Yeah, because that's much lower.
Yeah. Well, it basically the levels that are required under the Clean Water Act to discharge to surface water systems.
So are you discharging to Popper Creek? Or?
Depends on where we are. Generally...
Not Mitchell Branch, I hope.
No. At ETTP, generally we get it all the way out to the clinch.
Okay, good.
And we do it under what are called ambient water quality criteria standards that are developed to ensure the fish are all right.
Any questions? John?
In terms of that in situ treatment that you were talking about, you mentioned, I think you said it didn't seem to be feasible for the deep stuff because it would gradually pollute.
You have the potential to push things around. Yeah, it's
were you able to collect any data? I mean, by treating the shallow and letting it dilute the deep and treating it again in shallow, and that process would gradually lower the contamination. But were you able to collect any data that's how long that would take to do that?
We never actually deployed a treatment system. What we did at ETTP was to get a good handle on where the massive contaminants were, and then based upon that information and information from similar conditions at other sites, we're able to draw some conclusions, projections on the efficacy of these treatment systems. Just characterizing that site to evaluate what was there was about a $9 million endeavor. Putting those probes down into the ground could certainly rack up to a lot more than that. So we decided that rather than do that, we should get on with the broader study of alternatives, look at the site as a whole, think big and think focused, and look at the range of alternatives available and come up with some more comprehensive remedies for the site.
Any other questions? Yeah, Bill? So I'm sorry.
How close together were those wells? I've drilled wells, within 5 feet, within reaching. And
That's a
they
Dennis
two different
question.
waters.
Yeah, there were some of them within 20 feet of each other. Yeah, from one to the other. Patients against David mentioned there was 100 wells. Barely at one.
So there's approximately 20 feet apart. So
Yes. There was some that was maybe 60 or 70 from, but some.
Like I say, I've had wells, I had one man wanted as close to his other well as possible. Okay, so close. And got two different waters. Mm-hmm. And, that's why I was wondering about if they could get a pump and flow to try to clean that.
Yeah.
If they was determined that it's in the same crack, so to speak, if they could flow from here and draw it through.
Right. So that kind of helps me make an interesting point that when you're doing groundwater investigations, because of the what they call heterogeneity, basically the changing conditions as you move through the ground, there's always some uncertainty. It's what's the fable about the guy that tries to understand an elephant by touching it here and touching it there. Groundwater investigations are inherently that way. You get your information from a boring, you move over here, you create a boring. At some point, you have to accept the uncertainty that remains and make decisions based upon the information you've gained. And depending on who you are, you may have different tolerances for uncertainty. We think at the East Tennessee Technology Park, by the time we add in the extra 30 or so wells that we've agreed to very recently, we're at that break in the curve where it's time to start taking the available information and trying to use it to make some decisions.
Martha?
Is there an exchange of information and lessons learned with other DOE sites like Savannah River?
There is. We interact with our peers in the other sites. We also have brought in, and actually the board has access to this fellow. He's worked with the board. I can't remember his name. The gentleman from the USGS, what's his name? Dan Good, Dr. Dan Good with Princeton and the USGS. And he's kind of an independent groundwater, I would say, expert. His specialty is modeling, but we've used him and made him available to the board to, interpret all this stuff that we produce. But yeah, there's a lot of exchange. We probably have, I'd guess there are half a dozen to a dozen hydrogeologists associated with this project alone. A lot of them have worked at other sites. And in fact, the person doing the feasibility study for ETTP is someone who has worked at many, many sites. So he should be well positioned to help us take advantage of the latest science. Any other questions?
Other questions? Are there any questions from the public? Please use the microphone up there and identify yourself.
Yes, Tim Griffin with Ativa. Dave, thanks for a good presentation there. Two-part question. This might be actually one for Mr. Cattell over here. Can you give an update on the status of the groundwater modeling initiatives on the site? And then sort of a related question. The lab was the site of the NEIGHBOR program, Natural and Accelerated Bioremediation Research Program, and I'm wondering if any of the research work that was done there translates over to ETTP, recognizing there are two different sites.
Go ahead, Dick. You want to speak to the NADER lessons learned? Okay.
Yes, the NEIGHBOR activities that were conducted over at Y12 S3 ponds were primarily geared toward sequestration of uranium in the S3 ponds plume. Fortunately, we don't have much of a uranium and groundwater problem at ETTP, so there's not a direct tie across from that research work. That project has really come to its end, and the Office of Science work has shifted over to mercury investigations to the greatest extent. So what was the other question?
The status of our groundwater
status of our modeling?
Yeah.
Oh, the model construction is great. We've wrapped up in 2017 a regional groundwater model development. We had a presentation to this group, I believe, when we were wrapping that up. In the past year, we've been focusing on refining models, groundwater models for the ORNL area in anticipation of doing some more looking at investigations that need to be taken at ORNL in Bethel Valley in planning for some of the remedial actions over there. So we're actively continuing model development and doing simulations of various sorts for the ORNL site.
Yeah. An example, I mean, groundwater models have uncertainty too. That doesn't mean they're not useful. One thing that we've begun using the model for is to look at hypothetical scenarios where someone were to be over in that zone of generosity and start putting in a big industrial production well and pumping as hard as they could. What effects might that have on the groundwater plumes on the reservation? Might it pull it towards the river, under the river? Those are the types of things that we can do with the model. So it's going to be a really useful tool for us.
Yes.
I'm Sid Jones. I've got a loud enough voice. I probably will.
Please use the microphone.
They promised me that there wouldn't be anything new that I would. But actually, there's a couple of things. I've been gone long enough.
Okay.
So, and I would like to compliment you guys on putting some wells in out at Bethel Valley. That's the one place I always wondered if we didn't need to know a little more about what was going on. But there's a couple of things that came up there that that I hadn't kept up with at all. And one was the status of the tech plume out at K25. Is that primarily the result of the release and is that starting to attenuate since that was a one-time spill kind of thing?
Yeah, I don't think we have the data set, the temporal data set to allow us to say it's attenuating yet. It appears to have been contamination that made its way primarily, as I understand it, primarily into the utility infrastructure that was laid into gravel beds, and it ran along that and spread out from there.
Yeah. And the other thing, when you were calculating your mass of volatiles there were you assuming no DNAPL, or were you trying to take that into account somehow?
We absolutely, thanks for bringing up DNAPL. Tried not to use any acronyms tonight, but this solvent I've been talking about is basically a couple of carbon atoms with chlorine wrapped around it. And that's why I call it a halocarbon solvent. And it is heavier than water. So if you pour it onto the ground, it has the pesky habit of dropping through the soil column, hitting the groundwater table, and then dropping through the groundwater table, getting onto bedrock and percolating its way down into the fissures of the bedrock. So when I was talking about the blob, in some cases I was talking about a DNAPL blob, dense, non-aqueous phase liquid material. And that is a very, very difficult groundwater challenge. So no, we absolutely have been able to establish that we have areas where there is DNAPL blobs, if you will, in the subsurface at ETTP.
And were you able to, I'm thinking that I could remember that, but I'm wondering how you tried to take that into account in doing the mass estimate.
By the 100 wells, understanding where it appears that we have DNAPLs, a lot of assumptions, candidly, about the size of the fractures and all that stuff. We tried. Yeah, we gave it our best shot. It may be a conservative estimate. It's certainly an imprecise estimate, but we're pretty confident we got hundreds of pounds of DNAPL in that area.
Other questions? Yes, Christoph.
I've got one question. For the Melton Valley, DOE installed several wells on the other side of the Clinch River, and they're not being shown here on the map. So where's the status of these wells?
So we have several wells. We work with the Roane County Industrial Park, and we were able to put in some wells just out of the river valley, up on the tabletop, a series of 4 sets of 4 wells. And they're basically located right downstripe from the Mountain Valley Burial Grounds. So we have 4 wells in 4 clusters. Those wells are drilled to different depths. And we think they serve as a really useful monitoring system to see if anything's making it back from the river. And then we also have a collection of wells, generally private wells that used to be used for drinking water supplies. Part of the deal when we told people we'd give them the fresh water and the pay for the water was they had to let us use their wells as a monitoring system. So we have some in through there that we monitor also.
So they are still in existence?
Absolutely.
So they are still there?
Still in existence, still monitored. Yeah.
And if I can have another follow-up question for ETTP. So I'm seeing from a presentation that feasibility study milestone is September 30th, 2019. So with some additional wells that you is installing right now, and we're all grateful and happy that you guys were able to find funding, and be able to install them. Will this be enough time to get some good picture of that will assist in delineation of the extent of these different plumes that you have at ETTP?
Sure. Well, of course, I have to mention, that we've already got the 360 or 90 wells in that area that give us a picture. We're adding an additional 20-something to refine that picture. The goal would be to have those wells in and at least around a sampling done so that they're available to support the study process. Yeah.
Thank you.
Other questions? Okay. Isling?